Digital vernier caliper. We are living in a digital world, and the digital version of the vernier calipers are available nowadays. Digital vernier caliper figure 1.5 has a digital display on the cylinder, which calculates and displays the measured value. The user need not manually calculate the least count, zero error, etc. This is the digital vernier caliper. Screw gauge. Screw gauge is an instrument that can measure the dim, dimensions up to 1 by 100th of a millimeter or 0.01 millimeter. With the screw gauge is possible to measure the diameter of a thin wire and thickness of thin metallic planets. Wire and thickness of thin metallic plates. Description of screw gauge. The screw gauge consists of a U-shaped metal frame. A hollow cylinder is attached to one end of the frame. Grooves are cut on the inner surface of the cylinder through which a screw passes. Figure 1.6. On the cylinder, parallel to the axis of the screw, there is a scale with this graduated in millimeter. It is called pitch scale, PS. One end of the screw is attached to a sleeve. The head of the sleeve tumble is divided into 100 divisions, and it is called the head scale. This is screw gauge picture. The end of the screw has a plain surface spindle. A stud anvil is attached to the other end of the frame, just opposite to the tip of the screw. The screw head is provided with a ratchet arrangement safety device to prevent the user from exerting undue pressure. Using the screw gauge. The screw gauge works on the principle that when a screw rotates in a nut, the distance moved by the tip of the screw is directly proportional to the number of rotations. Pitch of the screw. The pitch of the screw is the distance moved by the tip of the screw of one complete rotation of the head. It is equal to 1 millimeter in typical screw gauges. Pitch of the screw equal distance moved by pitch by number of rotations by head scale. B. Least count of the screw gauge. The distance moved by the tip of the screw for a rotation of one division on the head scale is called the least count of the screw gauge. Least count of the instrument, LC, equals value of the one smallest pitch scale by total number of head scale division. LC equals 1 by 100 equals 0.01 millimeter. C. Zero error of a screw gauge. When the mobile stud of the screw and the opposite fixed stud on the frame area brought into contact, if the zero of the head scale coincides with the pitch scale axis, there is no zero error, positive zero error. When the mobile stud of the screw and the opposite fixed stud on the frame are brought into contact, if the zero of the head scale lies below the pitch scale axis, the zero error is positive. Figure here, the fifth division of the head scale consists with the pitch scale axis, then the zero error is positive and is given by z point e equals plus bracket n into LC close bracket, where n is the head scale consists in the case zero error equals plus open bracket 5 into 0.01 close bracket equals 0.05 millimeter. So the zero correction is 0.0 minus 0.05 millimeter. Negative zero error. This is the positive zero error figure. This is negative zero error. When the plane surface of the screw and the opposite plane stud on the frame are brought into contact, if the zero of the head scale lies above the pitch scale axis, the zero error is negative. Figure 1.8. Here the 95th division consists with the pitch scale axis. Then the zero error is negative and is given by ZE equals minus 100 minus 1 into LC. ZE equals minus 100 minus 95 into LC equals minus 5 into 0.01 equals minus 0.05 millimeter. This is the answer. The zero correction is plus 0.05 millimeter. This is negative zero error. Activity 2. Determine the thickness of a single sheet of your science textbook with the help of a screw gauge. 1.8. Measuring mass. We commonly use the term weight, which is actually the mass. Many things are measured in terms of mass. In the commercial world, the SI unit of mass is kilogram kg. In a case, the units are based on the items purchased. For example, we buy gold in gram or milligram, medicines in milligram, provisions in gram and kilogram, and express cargo in tons. Can we use the same instrument for measuring the above listed items? Different measuring devices have to be used for items for smaller and larger mass. In this section we will study about some of the instruments used for measuring mass. Common beam balance. A beam balance comprises the simple mass with a standard reference mass. Standard reference mass are 5 gram, 10 gram, 20 gram, 50 grams, 100 gram, 200 gram, 500 gram, 1 kg, 2 kg, 5 kg. This balance can measure mass accuracy up to 5 gram. Figure 1.9. This is common beam balance. Weight machine. Physical balance. This balance is used in labs and is similar to the beam balance, but it is a lot more sensitive and can measure mass of an object correct to a milligram. In figure 1.10, this is physical balance. The standard reference mass used in this physical balance are 10 milligram, 20 milligram, 50 milligram, 100 milligram, 200 milligram, 500 milligram, 1 gram, 2 gram, 5 gram, 10 gram, 20 gram, 50 gram, 100 gram, and 200 gram. Thank you. We will see this topic in next video. Thank you all.